All right, g'day everyone. So apparently, I lost all of the audio from all of the footage. Yippee! I tried to do this different trick with the headset, and well, it didn't work out. So yeah, pairing the headset to the phone and then recording the audio that way. Oh well, unfortunately, it is what it is. I have the Preselector built, and I have the Preamp built. So I'm going to go plug in the power supply and we'll start turning it on. Yep, power supply settings are correct. I can turn that on. So now let's just measure. I do have a signal coming in. I do need to actually fix this up. So stimulus, CW frequency, and then obviously the best frequency there. And that puts out a negative 10 dBm tone. It drops it by roughly 60 dB on this attenuator. Hang on, can you see it? There you go. There's a little attenuator that I've soldered up there. That's 60 dB down, feeds it into the receiver. So we can start testing things. First, I'm going to go check all the DC operating points. So we'll just chuck our negative there on the ground plane. We have, let's see, 11.63 on our main rail. It drops through the 100 ohm resistor to 10.15 volts, which is fine. We will go check the bases of the preamp. So the first base is 0.9 volts. And the second base is 1.7 volts. There we go, which is probably fine. We can go check the emitter voltages. So this will tell us our current. So 270 millivolts across 100 ohms should give us 2.7 milliamps in that transistor. On this one, it's a 1 volt, which should give us 10 milliamps on this transistor. Get 1 divided by 100, 10 milliamps. Okay, we'll check our collector voltages as well. So 4.84, as long as it's not near one of the rails, it's okay, because this is very low level. And the other one, 5.2, which is almost perfect actually, given that our rail is 10.1 volts. So pretty decent. Now we can go measure the RF coming around the thing. I have this very special probe made up. It's a bit how you're going, but it'll do the job. So I can get this multimeter out of the way. I can bring this closer. And if you can see it, there we go. We'll measure the input. Now, I know this is quite low signal. I see negative 80 on the screen there. So very low signal. Coming through the preselector, it's going to be the same. So be very careful to measure here. There you go. Yeah, it's the same very low signal. Hang on. Get that out of the reflections. If I can, that would be good. There you go, very same low signal. We'll measure from the first RF amplifier. So this will be a lot higher. 65 dBm, which is a gain of 15 dB. We'll measure from the second RF amplifier, basically negative 40 dBm. So in total, we have about 40 dB of gain in the preamp before the mixer. 40 dBm is fine at an S9 level. The mix is driven very hard, so not terribly worried about the signals getting overloaded or anything like that. Yeah, I guess it's all working, it's all fine. Unfortunately, I lost some footage where it wasn't fine. When I built this, I initially had this resistor here, the base to ground for the bias of the second transistor, the one that produces 1.7 volts. This is 220 ohms instead of 2.2 k ohms, which means my bias voltage was like 250 millivolts. Didn't turn on the transistor, so no signal got through the output. You know, so pays to double check the resistance values with a meter, but I was just kind of reading the values off with the colors, and I kind of missed that one of the things was black and not brown. Anyway, just to show you how close these two amplifiers are, the other side, 10.13, so this is the rail, very close. Our first amplifier is in the guts here. There's a bias, 0.9 volts, 0.9 volts. Our second amplifier is bias level, 1.7 volts. This one here, I think, 1.7 volts. Our collectors, I'll just go on the end, 5.29 volts, 5.2 volts. Very, very close. So these are fairly well matched. Yeah, I've measured them all before and basically perfect. So I guess the one last thing we can check is the gain of the first receiver compared to the second, but it's connected to stuff, so that might not be that helpful. We'll give that a pass. All right, so there you go. There's my RF preamp. Unfortunately, I lost so much footage, about 2 hours of it, and I've learned my lesson about doing this trick with the headset into the phone directly. Now, I actually do have a little bit of footage of me testing the preamplifier, and that footage was completely fine. So what I might do is I'll chuck that here on the end, and it'll show you just how sharp that preamplifier dip is, and how I actually thought it was going to be a little bit worse than it was. All right, now we have 100 ohms here, 100 ohms here through the preselector. If this was perfect, which I can guarantee you it's not, then what we should see is a nice dip at 40 meters of a 1-to-1 SWR because it sees 50 ohms. I know that's not going to be the case, but we are going to see some type of dip. We'll also see infinite SWR on the other frequencies because these transformers will short them out. So we're going to plug in. What do we see? I do not know if you can see this. Actually, that's a lot better than I thought it was. I'm going to bring you down if you can see it. That's exactly what I was expecting to see. Well, actually, this is better than I was expecting to see. 1.2 SWR at 7.1 megahertz. Everything else is pre-selected and shorted out. So the way you can tell it's shorted out, lower frequencies is near the short circuit, and upper frequencies is also near the short circuit, and actually starting to get into the capacitive region, or inductive, I think. It doesn't matter. The point is we have some type of pass characteristic here with the 200 ohm resistors down to basically 1.2 SWR to 1. Might recall my 40 meter profile. Oh, actually, that's better than 1.2 to 1. Yeah, that's really good. Okay. Well, maybe we accidentally made a very good preselector. I knew it was decent, but yeah, I'm happy with that. How can you complain with this? And that's all I have. Unfortunately, yeah, losing that audio is really not great. However, maybe I'll record myself building the audio amplifier because it's kind of the same type of build as the preamp, same circuit, same type of transistors. So yeah, we'll go for that. All right, 730 VK4 Delta Lima.